start with my relationship between v and x. The relationship that's true all the time between v and x is that velocity is the derivative of position with respect to time. That's always true. My velocity I got from the previous part as t squared plus 3. Okay, I'm trying to solve for x, or position. Roger, what should I do first?
Separate the variables.
Good. And do what to do that?
Multiply both sides by 2.
Yeah. What next, Eric?
Integrate both sides.
Yep. What next, James?
Both sides, you gotta put your initial conditions.
Okay.
So it's gonna go from
To the left side.
0 to t, and then the right side's gonna go from 5 to x.
Excellent. No pun intended. Fred, let's integrate that.
T to the third to the 3. Plus 3t.
Okay, and then integrating the right-hand side, Sean?
X, and then the straight line from 5 to x.
Okay. We'll put our t in for t, and we'll subtract off the 0 in for t, which gives us t cubed over 3 plus 3t on that side. Then on the right-hand side, Benson, what does that give us?
X minus 5.
Yep. And finally, what is x, Edgardo?
X equals 3 cubed over 3 plus 2.
Plus
3.
3t.
Right. Plus 5.
Yep. So my position as a function of time. Is that. And I've now finished the problem all the way to the end. So we've got our position as a function of time and our velocity as a function of time. If I wanted to know the velocity when time is equal to 2 seconds, so how fast is this particle going when time is equal to 2 seconds? All I need to do is plug in a 2 for the t. However, there was no way to shortcut this. I had to do all this work, and now that I've got my answers, now I can answer some of these other questions. So the velocity when time is equal to 2 seconds is what? Anybody?
7 meters per second.
Yep. Where is the particle when time is equal to 1 second? Anybody? 8 1/3. Correct. So and the questions could go on. When is the velocity equal to 4 meters per second? What time is the velocity equal to 1 second? Time is equal to 1 second. So you set this equal to 4 and solve. When is the velocity equal to 0?
Never.
Never. Okay. I like it. So I'd have 0 equals t squared plus 3. Move the 3 over, I get negative 3. T squared equals negative 3. The answer is going to be a complex number. So a complex number, as maybe one lesson you might have learned in circuits, a complex number isn't always to be discarded and thrown away. It can have useful meanings, but you need to be able to interpret it if you're going to know what that meaning is. So by default, if we don't know what that meaning is, we say, now it's not going to happen for any real amount of time. Okay, let me give another example. This is a more common one, but I want to go through this exact procedure. I don't want to use a shortcut you may have learned from Physics 1. I want to use this longer procedure because it works for every situation. Suppose we're